In this video, I'm going to demonstrate how you can use Power BI to connect to exported Revit data that was produced using the Tracer add-in for Revit. The Tracer add-in for Revit will take your current open document and harvest it to an external SQLite database file that you can then use to connect into Power BI and perform analysis. So what I'm going to do is I'm going to go back into Power BI here, and I'm going to choose Get Data. And what Get Data is going to do is it's going to open up a dialog that shows us a listing of possible data sources. With Power BI, you can connect to a wide range of data sources, everything from Excel files to databases to websites and other protocols. In this case, what we're going to be doing is using the ODBC connection. ODBC stands for Open Database Connectivity, and it's a fairly standard protocol for engaging with external databases. So I'm going to hit connect, and this is going to open up a dialog for how we want to connect to this ODBC connection. So I'm going to go under data source name. I need to expand this. I want to make sure that we're specifying the SQLite 3 data source. The exported tracer databases are SQLite in nature, so we need to make sure we're specifying that data source name. And then I need to expand advanced options. And advanced options allow me to specify the connection string, and in this case the connection string is going to represent the path to that database. So what I need to do here is type in database equals, and I need to go to my file browser and find a database file that I want to use. This is a folder that has some databases inside of it. You can see it has the extension .db. And I'm going to do a shift right click and copy as path. I'm then going to jump back into Power BI and paste that path into my connection string field. And I also want to remove those quotation marks at the front and end of that string path. I'm then going to hit OK. And what Power BI is going to do is it's going to prompt us with this login screen. This login screen, because we're dealing with a SQLite file, is a bit superfluous. There is no credentials per se to log into the SQLite file that's produced by Tracer. So in this case, I can just simply go to default or custom, and I don't need to enter in anything. I can just hit connect. And what this is going to do is it's going to create a connection and display a navigator of the available data inside of one of these Tracer exported SQLite databases. And what you're going to see is that there are numerous views and database tables to draw from. Some of these tables are kind of internal SQLite tables that have no bearing on the Revit data contained. Some of these are core database tables that are containing the raw Revit data that's been exported. And then some of these are views that create summarized lists of specific elements that can be helpful for some form of analysis. In this particular tutorial, I'm going to focus on a couple of key tables that you're going to want to draw in. And these tables represent the relational structure, the core relational structure of the Revit data as it's been exported. And those tables are document, document parameter, element, then element parameter integer, element parameter number, Revit parameter, Revit ID, and Revit parameter text. And what these tables do is they kind of form the core set of element records for the Tracer SQLite database. And this allows us to access information at the document level. We can then access element records, and then for every element we can access the parameter records that exist there. And so after we have those set out, I'm simply going to hit load. And what Power BI is going to do is it's going to make connection into that SQLite database and pull in those model records. And each of those model records are going to be exposed as a set of available fields inside of Power BI. You can see that we now have reference to the document table, the document parameter table, which represents your project information, for example, your element list, and then the element parameters. What's important to do at this stage is to verify that the relationships between these tables are properly established. So what I'm going to do is go to the model section of Power BI, and so we can see these tables arranged. And what Power BI is going to do when it first brings in a new data source like this, it's going to try to establish and infer where the relationships are. Power BI is sometimes good at this and sometimes not so good at this, and oftentimes it misses some information. But out of the gate here, you can see that document and element are joined on the document ID, which is correct. Document is kind of our highest level table here. It's showing the kind of some base document information in terms of where that document came from, some identifying information. It's also pulling forward information about Revit version and so on. That document table is linked. Power BI automatically linked it to the document parameter table. You can see that's also linked on document ID, so that's correct. And then we have element here, which contains the element list. So this is every element that exists inside of the model. We can get information about the element's category, its location, the Revit ID, so the Revit element ID that comes along with it, and so on. And then it looks like we have some orphaned tables here. They're not connected into anything, although they should be. And this is where we need to draw a couple of relationships in order to get the Power BI workflow set up properly in order to get the kind of relational integrity going between all tables here. So I have these element parameter tables, and you can see that there is a, under the element table, an element ID field, and then an element ID field inside of each of these element parameters. And what I can do is establish a relationship by clicking on element ID and dragging it into, say, element parameter text and hover over element ID. And what this is going to do is it's going to create a relational join between these tables. So now element and element parameter text are joined on element ID. And I'm going to do the same for all of these other parameters. And just by simply clicking and dragging element ID onto element ID, like so. So now we have this relational structure established that's joining between the element records and the associated element parameters. And so now this looks like a complete set of joins between tables. If you're ever curious about these joins, you can always right-click on them and go to Properties, and that will display exactly how these are being joined, and if they're many to one or one to many. If you want to go single direction or both direction, that's all well and good and up to the user to kind of determine. So now that I have these relationships set up, I might be able to demonstrate some ways of working with this data and how this relational structure can become useful in the Power BI context in terms of creating a report. To kind of demonstrate a little bit of this workflow, I'm going to simply pull out a table. So we have a table widget here inside of the report, and I'm going to expand my element table. And my element table, I want to display category. So this is now going to list the categories that are available. I'm going to list my element ID, like so. And I'm going to list my element name, like so as well. And you know what, I'm also going to list the type. So type is similar to category. Instead of capturing the category of element, it's also capturing the type of element. And that's kind of in a Revit context, whether something is like a family or whether it's a kind of a ceiling object. There's some parallel into category, but it's not always one-to-one. It's kind of useful to have these pulled out separately so you can filter them. So if you wanted to find all family instances in your model, you could use the type column. If you wanted to find all of your rooms, you would use the category column, for example. So now I had to have this list of element IDs and element names. Maybe I want to filter this list a little bit. So I'm going to create a slicer here off to the side, and I'm going to use the slicer and use the category field from element, like so. And now what I can do is like, okay, well, I want to return all of the doors that were in my model. And so what that's going to do is it's going to use the relationships that we established, and that's going to return a record of elements for every single door object. And and now I have this running list, and if I wanted to get into floors and just show me all the floors, it's going to find my floor types as well as the floors. And so this is where the type filter can also become useful. So maybe I'll pull out another slicer that looks specifically at type. And let's say I just want to see floors. So that's going to remove the floor types from that list. But if I wanted to see my floor types, I can of course toggle back over to that, and it's going to find the floor types, and then it's also going to filter the floors. So now we have this filtering happening. But now that I have these element records, maybe I want to pull up some data that are specific to some of these elements, right? So this is giving me the fact that there is an element that is present, but I want to be able to pull out some data from these objects. And that's where we can start to rely on these parameter tables. And in Revit, parameters are stored in one of four ways. In the API level, you can either pull out integers, you can pull out numbers, you can pull out Revit element IDs, which reference other elements, for example. So like a floor may have a Revit ID associated to the level it exists on, which will allow us to find that level. We can also find some text parameters. In this case, I'm going to be interested in some of the numeric data here. So I'm going to pull out another table. And in this table, I'm going to start to make reference to some of the numeric parameters over here. And to kind of demonstrate this, I'm also going to pull out the element ID here. So we can see that we have that element ID. Power BI is summarizing this, and I don't want it to summarize the element ID because it is, in fact, a number. And it's going to try to do a count of those. I'm going to do it like don't summarize, which would list out all the element IDs in my table. And I'm also going to pull out the name of the parameter, and I'm also going to then pull out the value of that parameter. So here you can see that we're capturing for all of these floors here. We can trace it back to its element ID if we wanted to, and find the object here. We're also then getting all the parameters that are associated with that floor. So if I wanted to drill down into one of these specific floors, let's say this one here, I'll just do a row selection. We've now filtered that element parameter list, and now we're getting a listing of those parameter values, similar to looking at the property editor in Revit. You would see a similar list of parameters inside of Revit if you were to click on that particular element, right? So that's all interesting in a tabular exercise. Of course, one of the powerful aspects of Power BI is the idea of creating visuals and visuals based on graphs using this type of data. And so what I want to do is I want to create a graph that for this list of floors displays the comparative areas of each floor in the model. So what I'm going to do here is I'm going to deselect my visuals, and I'm going to choose the stacked bar chart, pull that out here. And what I want to do is I want to pull out the name of the floor. So I'm going to go back to the element table and use the name field as my axis. And then I want to use the value field as from element parameter number as my value input for the visualization, like so. And what this is doing so far is that it is computing all of the numeric values that are available here and displaying those in a bar chart. So right now it's not distinguishing between numbers such as area, elevation at bottom. It's kind of adding those all together. So we need to add one more layer of information to this visual. And this layer of information is going to be the name of the parameter. So I'm going to take the name field from element parameter number and bring that up to the filters of the visual. And I'm going to check area, and it's going to now exclude all the other parameters. And now we have an area chart here. So it's basically saying that for this hollow core plank concrete topping floor, that's where most of the area is, and then we have some other floors down here that are of less area. And of course we can go through all the standard ways of formatting this if we want to show data labels and and do other things to that we can. But now this is kind of interesting because what I can do is click on this table, and it's now going to filter both my elements table that I had going on here as well as my element parameter table. And this also works both ways. So if I click over here and click on this row, it's going to identify the sliver of area that this particular floor takes up. And maybe if I click on this one, it's going to show me the proportional amount of area that this particular element is taking up in this summarized chart. So that's the overall basics of connecting into the SQLite data source, and we're using these tables in particular as our relational tables. There is another aspect to this that I think is important, which is using the views. And so while this is allowing us to navigate the core relational tables inside of the SQLite database, we also have this ability to use some of the views that are provided to get more summarized and kind of direct data about specific things. So what I'm going to do is I'm going to go to recent data sources here and go back to my ODBC connection that I established earlier. It's going to jump me back into that navigator. And you can see that we have all of these views here. And we can see that if we wanted to pull in just the grid elements, we could. If we wanted to get just the floor elements and get a table of those, we could. So here's an example of clicking on the floor elements table, and we now see a set of floor elements very similar to the list that's pulled up here, but it's, we don't have to worry about any of the relational components. We just can pull out just those elements. So I'm gonna go ahead and click on that, and maybe what I'll also do is click on the room elements table down here, which will pull up a listing of all of the rooms. And so I'm gonna go ahead and load that information in. So these are, in some ways, tables or views of convenience. If I were just concerned about those specific elements, I can get an itemized list of those elements and the parameters. If I want to kind of snoop through that data a little bit, I can always go to my data tab here off to the left in Power BI and say, okay, well, let's take a look at those floor elements. And now we have a list of those elements here. We have the element name category. This is element location, which is compatible with the tracer visual, for example. Then as I scroll over, you can see that we're getting all the data, and as their parameters indicate, available in each of these fields, right? These columns contain, the area information and the height offset from level, for example. And then if I look at my rooms table, you can see that we're getting a similar type of element record. And now instead of floors, it's now the room objects, and we can get all of that information for every room, including associated objects, and as well as text information on name, number, and anything that's really assigned to the room comes across in this table. Which means that, if I'm in my report and I go, I'm going to add a new report page here, I can go and say, you know what, I'm going to get in here and start to construct a visual that is based on room area. So I've got a stacked bar chart. I'm going to expand room elements, and in this case I want to pull out the room name, so that's going to be the axis. And then what we'll be able to find as well is the area, so the value of area. And now we have a listing of all the rooms and their associated areas. And if I wanted to repeat maybe the visual from the first table as well, I'll pull out another stacked bar chart. And I'll instead expand floor elements. And here what we can do is start to look at a couple of opportunities in through here. We can see that we have a maybe the type as our axis, and then what we're going to do is do area as our value. And now what we do is we're getting a list of the floor types. These are floor type IDs, of course. So maybe what I want to do is I can start to use some of this other information as well as drivers for this information. If I wanted to, maybe I want to choose level or elevation or some of these other components, which is all just fine. It means that we're looking at the information a little bit differently here. So that's the use case for the views that are provided versus the core tables that represent the actual element relational structure. So hopefully this is a useful overview for you. We covered a pretty wide range of topics. We covered connecting into the data source. We connected and looked and reviewed the tables from that data source and formed some relationships, connected those together, and then we also brought in a set of views that represent the data, perhaps transposed or pivoted a certain way that allows us convenient access to those data elements.